traveling, that will not be able to be with us in the body, but will be with us through the technology. This is the title of the presentation. This slide will come up again when our very beloved advisor, Dr. Kawamura, will start his presentation about really what is going to be exploding, as already has shown for explosions. He's one of the pioneers because he has foreseen this when nobody else has, and the evidence is very simple. We got all our funding from Japan. Now, none of the US companies has foreseen the explosion of the service robotics besides Dr. Kawamura. And through the grace of God, Dr. Moanis Escaros has met him in '89, and he applied to Vanderbilt, and I caught in his tail as he was leaving, gave him my application to Vanderbilt. He started in the fall of 1990, and I got the blessing of starting in the spring of 1991. And one of really the grace of God labs and the presence of a very visionary person, Dr. Kawamura, that he embarked on a field that was a winter of it. There is no, I didn't deliver what I promised, and neural networks became also didn't solve the problem, so people left it. But he started this lab completely on his own, and we got really the pleasure of serving not with just a professor, but really a mentor, a father, very personable person to serve with. And it was really very, very like home for all of us. Quick presentation, official presentation of Professor Kawamura. Dr. K, or Kaz, is an internationally known researcher in cognitive systems and service robotics, service robots. He has published over 150 research papers in the fields of intelligent and cognitive systems, humanoid robotics, and human-robot interaction. From 1980 to 2015, he was director of first Intelligent Robotics Lab and later Center for Intelligent Systems at Vanderbilt University, and I would like to add to this US-Japan Center for Technology Relationships. And we got the pleasure of traveling to Japan because of this gift to us. And I should have put a slide of it, I have it at home, first international or worldwide workshop of human-robot symbiosis, which was done in Japan, and we got to rub shoulder with people that you will see, like Boston Dynamics, for example. Mark Rabert was one of the people in this workshop. This was done in 1994, probably, or 1996. So, 94? Yeah, we all went and got this pleasure of meeting the giants of robotics now. 94, was it? 94? Okay. So, I just wanted to add this here. It was a very, very important landmark. This was the first human-robot symbiosis worldwide workshop, and had who is who in robotics today was there. Center for Intelligent Systems at Vanderbilt University. In 2000, he was elected to be a fellow of IEEE, the world's largest professional organization in electrical and electronics engineering. I'm glad to have students here to aim in these directions. His lifelong R&D activities was published in the 20th anniversary issue of International Journal of Humanoids Research in 2023. Just yesterday, he was surprised. He's right here. He didn't know that he is actually the recipient of the Lifetime Achievement Award that gets offered in the International Conference on Robot and Human Interactive Communication, known as ROMAN. And Dr. Kawamura was one of the founders of this conference itself. He was just telling me in the car now that it was an award for human lifetime achievement, but he didn't know who was the recipient. It was vacant, and he was pleasantly surprised that it was him. We have also the wonderful wife Ethel, his life partner and wife, and we've got the blessing also and the gift of seeing her as grad students, and it's a great, great pleasure of you. It's very humble on their part to be present with us, and he told me, even if there's one person attending, he would love to give it. Somebody with that caliber to get this attitude. It's something that's for all of us to learn from. Let's give a warm hand of applause to Dr. Kawamura for coming and presenting to us.
Good morning. How's everybody? It's my great pleasure to speak to you. I just spent a week in Pasadena attending the technical conference. It's a lot easier to speak to the audience in the technical conference. So it's a challenge for me to speak general audience like you, and hopefully my presentation will be somewhat informative and entertaining. Okay? So if you excuse me, I would like to take off my jacket. This is not my professional style these days. Okay, so let's get started. Now, when Father Gregory approached me, he and I discussed what would be the interesting topic to you, and Father Gregory suggested service robot. This is the term I basically coined probably more than 30 years ago when I was a member of IEEE Robotics Automation Society, and the way we develop new technology is to set up technical committee. So I was the founding chair of the technical committee on service robot. And of course now nobody knows I started this term, but today I would like to discuss the past, present, and of course future of the service robot. By the way, if you have any question, please interrupt me anytime. Technical conference like I spend in Pasadena is always noisy, chaotic, so it's quite refreshing to talk to you in this very nice environment. By the way, I first gave a lecture in Cairo 35 years ago. Met some of these young fellows. So this environment reminds me of the trip we made in Egypt. Anyway, let's get started. So, he already went through. Okay, this is supposed to be my slides from now on. Doesn't go. Oh, I went backward. I'm sorry. Age shows you these days technology advances too fast. So I want to start this presentation with this slide because many people don't know the history. When you are in high technology, you think history doesn't give you any information, but it's very important for you to learn history. That will give you the perspective of where you are and where you want to go. Okay? So what is a robot? Well, probably you all know a robot is an electromechanical system. Okay? That means primarily it has a body and has some electrical system component to move this body. So that's the basic broad definition. Designed to perform various tasks, either autonomously, I'll show you some autonomous robot, or under human control. Okay? So in scientific terms, a robot can be defined as a programmable system. Okay? I'm sure you all learned some kind of programming in school. During my age, machine code was the way. you don't want to know, because that's one reason why I didn't go to computer science. That was very tedious way to program. And then we went to Fortran, and now Java and all kind of fancy software available. But anyway, in robot, you have to use some kind of software to control that and carry out complex tasks using a variety of sensors. So, yeah, we have, let me see if I can. We have a mechanical part on this side, a robot, which uses sensors and also actuators. Actuator, in the case of human, is a muscle. We use muscle to move. In the case of robot, say we use motors. And, in the robot, we worked, and these folks used pneumatic actuator. Yeah, but there are many actuators, and in our case, muscle. Okay. And then we have some software and interact with people. So these are the basic systems framework. Now, lots of people don't know, but robot technology is not new at all. It has a long history. Origin of robot is basically traced back to mechanical figures called automaton. Okay. Now, automaton is a moving mechanical device, and I just show you a few historical examples. If you go to the museum in Europe, you see those mechanical figures typically use gears and some kind of lever to move these gears, and then these mechanical figures moves. Okay. Now, there are lots of automatons in the world, but probably most famous one was the one in Prague, Czechoslovakia. Well, I'm sorry, now it's Czech Republic. They are two separate countries now. And they are 600 years ago. And this mechanical figure is sitting on top of the city hall, and when this big clock hit noon or 1 o'clock, the open door, window open, and these figures comes and play music and other things. Okay. So this the origin of robot. And technology got a little bit more sophisticated. So in the 18th century, French engineer made more complex autonomous robot or automaton. Okay? And one of his most famous robot is called digesting duck. So interesting about this robot is first time people can see the inside, while the previous automaton is basically you see outside, like a human, and you don't know how this is being designed. But this duck has a beak to go up and down and pick up something, and then it's a mechanical gear, etc., which will move this. Oh, I'm sorry, I should use here. Mostly I use mouse, so this is a new technology. You have to bear with me. So this duck will open us, pick up the hood, and then push this down, and through this mechanical gear system it goes down. and then eventually it goes through this tube, and after a while, this food will pop up outside. So you see this digesting duck, although this duck obviously couldn't digest, it just transferred from the beak to the end. But you see the autonomous robot. And over the years, there are more complex automatons have been invented and displayed. Okay? And if you go to the museum in the United States or Europe, you see some of these. Now, so the robot, so far everybody used the term automaton, which comes from Greek term, but the term robot was first originated or used in the Czech language. That's where the robot term comes in. And in the Czech word, robota is the original term, means forced labor. Okay? So you can imagine an earlier robot was all sort of service robot in a bad sense. It's a server serving owners. That's the term of robot originally. Okay? So this robota was used by this Czech writer Kapel Kapek, and his work was introduced, translated into English in 1920, a long time ago, 100 years ago. And his work was displayed, or play was displayed in New York in 1920. So this is the first time Americans learned the term robot. And as people say, the rest is history. Now everybody in the world uses the term robot. Okay? But the origin came from this Czech writer. So you learn the new knowledge today, hopefully. So related to automata is a term called automation. And my field, when I was a university student, was called control. And there's still many universities offered course in control. And control is a term, as you can tell, you want to control your wife or control your dog. You know, that's the meaning of control. So control is applied to machine, and idea in the machine manufacturing is to control machine. And this whole process is called automation. And this is the beginning of robot technology applied to industry in the world. So, this was early 1980s, still long time ago. But this was the time already I started my work in robot technology. And at that time, only robots available was like this huge industrial machine trying to paint the robot or do some other thing. Okay? And normally, this is not particularly useful for service robot. Now, there are three persons who gave me the inspiration when I started robot work, service robot work. Remember, there was no service robot at that time. So how do you start? Well, that's a good question. If you want to get into the new field, you have to get some inspiration from old technologies. That's the only way to invent new one. So how did I do? Well, I looked at, of course, this Czech novelist work. He did very interesting work, or novel or play involving humanoid. Okay, so I got inspiration from that. And then there's a famous medical doctor who turned into the science fiction writer. His name was Isaac Asimov. Okay. So I was very fortunate to listen to his lecture right before he died, and I got the inspiration in him. And as a matter of fact, our robot was named Isaac. The only difference is Isaac Asimov, just like Isaac Newton, had double A, but our robot has only one A. And I used to tell media people, our robot tend to be intelligent, but not as intelligent as Isaac Newton. That's a part joke, right? And then the last person I got the inspiration was Dr. Joe Engelberg. Again, I was very fortunate. I met him, and we even had a member of panel discussion to discuss future of humanoid one time. But he gave me lots of inspiration. So these people popularized robot. Okay? And if you are interested in science fiction and even robotics, I strongly recommend you to read one of his science fiction. This is a collection of short essays called I, Robot. And in this particular essay, the chief science is called Dr. Susan Calvin. And she was the chief robot psychologist. Now, this is very, very visionary, because these days, if you go to a technical conference, everybody talk about intelligent robot, how AI is influencing robot technology. But these days, you need more than just mechanical or electrical engineers and AI people. You need a robot psychologist, even linguist, or in my field, neuroscientist. So I don't want to scare you people, but engineering education is not enough these days. But in 1980s, Dr. Asimov already invented this robo-psychologist as a chief engineer. So that was quite a visionary people. But anyway, she worked with this humanoid, and the interesting thing about this story is humanoid was used as a slave labor, which is the original meaning of robot. And after a while, these humanoids get smart enough that they start talking to each other, and they decide to make a revolution. So they went to the owner's office and caught him and took him away. I don't think the robot killed him, but anyway, they became the owner of the robot factory. That's a very interesting story. Oh, okay.
It's a very, very fun movie to watch by a very funny, famous actor called Will Smith. You all know him.
Thank you, Father. Gregory, I'm not a big fan of movies. Used to go to the movie theater, but stopped doing that. Okay, so if you read Dr. Asimov's robot, he proposed so-called 3 laws of robotics. And this becomes sort of popular laws to be taught in the School of Engineering all over the world. So you can tell how science fiction influenced real world. The first law is say this: a robot may not injure a human being or through inaction allow a human being to come to harm. Now this is a very interesting law. In the 1980s, as I showed earlier, only robot in use was this big industrial robot. And if you go to the auto factory, etc., there's always big screen between workers and robot, because these robots are very dangerous, and if you go across, you might be killed. So what he's saying is future robots should be a little bit more intelligent. Okay? So solution, well, of course, nowadays we all use sensors, so if you see human robot coming close, you can stop, you know. So this is not a difficult law to satisfy. And then second law says a robot must obey the orders given it by human beings, except where such orders would conflict with the first law. In other words, if somebody tell you to go and squeeze this person, if you think it harm this person, then you shouldn't do that. Now, this law is more difficult to implement because robot has to have some kind of intelligence to see whether this robot action will harm somebody or not. Always in engineering said, well, let's try. You don't want to squeeze people and say, let he or her scream, then say, oh, that was a bad action. Well, we don't want to do that, right? The interesting similar story to airbag. You know, when airbag in all the cars start flashing, say, well, this airbag has some problem. How do you test? Hit the car and see if airbag works. But you don't want to do that to test it. So how do you satisfy this law? That's not easy sometimes. And then the last one he said was a robot must protect its own existence as long as such protection does not conflict with the first or second law. Now, this is the most difficult one, and this law leads to the question, can the robot have a consciousness? Now, this is a still issue sometimes technical community love to discuss. And some people call this type of robot conscious robot. I call it cognitive robot. But anyway, this is the current technical front in robotics. All right. So this was the state of robotic technology in 1981 when I started, and the robot was called 3D robot. Now, for you young people, if I mention 3D, you said, oh, 3D printer, it's a 3-dimensional, we know what that is. But nobody knows what 3D robot is. Now, in 1981, this represents 3D, which is dangerous, dirty, and dumb. Okay? So, why it's dangerous? Well, during this industrial robot age, there was no sensor attached to the robot. So robot was doing basically blind. Okay? So you can tell robot to move left and right, but robot doesn't care whether that will hit you or not. So we always told it's very dangerous to get too near robot. So there was no way to work human-robot interaction at that time. And dirty because electric motor was not well developed to move this heavy body at that time, except power plant, etc. So we tend to use different actuated force, like oil. Oil was the most popular medium used at that time. So if you go to the manufacturing field like this, there was oil everywhere, very dirty, so it's called dam. And the final one is the dam. The industrial robot didn't have any brain, except it was just follow the programming. So we used to call it 3D. Please don't consider this as a three-dimensional robot. Of course, it is three-dimensional. All right, so here comes the real topic, service robot. Okay? So what is a service robot? Well, service robot is a type of robot designed to perform tasks that assist humans in various non-industrial environments. So when I started the robot research, only thing available or being used was the industrial robot. And I didn't like industrial robot. I wanted to start designing and using robot which can work with people directly. And so one of the meetings we had in IEEE Robotics conference, we discussed what would be the good term. So they asked me to form a technical committee. So I got together with two other people and we decided our technical committee's name is Service Robot. So that's how name came. So service robots are typically used to improve efficiency, convenience, and safety in everyday activities. So now you can see the origin of the robot you see everywhere these days. And a good example is a robot helper. And this robot is called Pepper. I don't know if any of you have seen or heard of this robot. Okay, this is very popular these days. It's originated by a French company and improved by a Japanese company. So, what's important in the service robot compared to industrial robot? Well, of course, you have to have a different design. And you have to have a brain. These days it's called AI. Everybody's talking about AI. And of course we have to design system which can work with human. And these days it's called human-robot interaction. So the conference just went is international conference on human-robot interface. And many more. So, this is where I started my work in 1982. So, looks like ages ago, 40 years ago. I started my robotics lab with one graduate student. And this student was an older student, much older than I. So when we had demonstration, everybody thought I was his student. But anyway, we designed a very simple system, just like industrial robot, but it's a small scale and people can push it, etc. And so we call that Bandy 1. And we still have this Bandy 1 in the control lab at the Vanderbilt. Then we develop other different kind of robot. This is one of the robot we named Robin, robotic inspection. So this robot is supposed to be inspecting problems, cracks in a bridge in the United States and all world, inspecting problem in bridges is not easy. So they use lots of inspectors and inspect each robot every maybe 10 years or 20 years because they don't have enough people to do that. But if you develop a robot, you know, you don't have to worry about it. You can do it every week. So we developed this one, and we had the US patent. I don't know if Dr. Scarlett was involved. Probably you were involved. Here is one of the originator. If you have interested after the talk, please talk to Dr. Scarlett. And then I have this great memory picture. Can you tell who this gentleman is in the middle? He's our great father, Gregory, young days. But anyway, he was working on the computer vision, and he designed the head of the robot. So we had, this is the one on the left is the earliest robot we made with just one arm feeding people. And then we applied this robot technology directly to interact with human. So this is the world's first service robot doing rehabilitation work of the human. And later, last year at another robotics conference, the Chinese company called Shanghai Fourier Technology Companies. They basically using the same concept, using newer technology, and got the award. So you can see concept at this time was now used and commercialized. And unfortunately, we didn't apply for a patent, so we didn't get any loyalty out of these Chinese companies. So this was the earlier application. And some of the hospital in New York applied this technology in 2000. And this was a very interesting service robot application. The Isaac robot is very difficult to control. Dr. Isaac can tell you all the detail because he was in charge of control part. Because pneumatic actuator-based robot arm is just like human arm. Our arm moves very robustly, but it's not good for doing precise work. Okay? So we cannot, medical doctor cannot use his or her hands directly to operate us. They always need tools. And similarly, this Isaac was very difficult to control. But one application we found, which doesn't need this accuracy, was called theremin. I don't know if any of you have heard or used this musical instrument called theremin. It's an interesting application of electric technology. And here's vibration part with antenna, and to play this theremin, all what you have to do is put arm either near or over the move. Then this will play some kind of music. Obviously, they cannot play Bach or Beethoven, but still, you can hear some music. So I thought, well, this would be an interesting way to demonstrate usefulness of a robot. So we did this demonstration, and boy, everybody in the world wanted this robot. And I got the call from one organizer of the big festival in New York. They like to show this robot technology. Unfortunately, our robot at that time needed huge air source to move this arm, So you can't just take this arm and move somewhere, because then it won't work. You got to have this huge source to go with it. So we had to decline. But anyway, I got lots of interest. And this is the showcased further glory developed Isaac Vision System. So, yeah, he is the originator. Now, so this may not be directly useful for you, but to develop robot system, you need lots of people. Okay? And two key ingredients for success are this: good vision and a good team. Okay? Now, why do we need a good vision? Well, just like I got the impression from Dr. Isaac Asimov's book, sometimes different field will give you some vision. If you just talk to the engineer all the time, your vision is kind of limited. So you have to expand your horizon and have a good vision. That's very important for robotics. And of course, good team, because robot technology development needs from electrical engineering, mechanical engineering, computer vision, computer AI, even psychologists, neuroscience, etc. So you need lots of good people. So I was lucky I had a good team, and here are the two of them as a living example. So we started with one arm, and then by year 2000, United States had 3 major research centers doing humanoid research. So these are the 3 teams. One in the middle was led by a good friend of mine, Professor Rod Brooks. He started MIT AI Lab and started this humanoid called COG. And the second one is the government research group at Houston. It's called NASA Johnson Space Center. And they start developing humanoid, which I was told it was shipped to the International Space Station at some point by the president order, but apparently they couldn't use it up in the space, so it's just sitting somewhere within the International Space Station, apparently. And the third one is our group, Isaac. And we had lots of good people. The lady at the end is, let's see if I can, yeah. She got a PhD from us, and she went to the NASA Johnson Space Center because we had a joint research project. And right now she's chief manager of International Space Robot Collaboration. So she goes to European Space Agency all the time. The funny story about her first name is Kimberly, so we always call her Kim. When we encouraged her to go to the NASA Johnson Space Center, she visited, she said, Dr. Kawamura, I don't want to go there. I said, what? Houston is terrible. Humid. So I was surprised. Finally, he decided to go now. And now she's very happy. So you have to be careful when you choose where you want to go. First impression may or may not be the right thing. Now, one of the innovation I made in the early days is when you design the human, robot, of course, robot needs software, so you have to design the system. We call it system architecture. Okay? So you need more than just programming skill. You have to have some kind of system architecture design skill. And there are lots of people who knows how to do it. If you talk to the people in Dell or IBM, you know, when you design the computer, of course, you all have to design system architecture. Now, what's the difference in robot working with people? Well, I said robot has to have some device or element or subsystem, whatever you call, which will represent the people you work with. Okay? So we adopted so-called multi-agent system architecture. Now, this is a little bit jargon. I apologize, but in computer science, this is one way to do the system architecture. And one of the agents we try to design, I call it the human agent, which represents human. And unfortunately, at that time, only student I had was engineering student. And they didn't have any background in human science or psychology. So their human agent, in my judgment, was totally inappropriate. You know, they could represent height and weight and what have you, typical features of the human. But we couldn't represent whether this person is grumpy or need extra assistance. So we gave up after a while. But I thought concept of agent-based system architecture is well suited in human-robot environment. So over the years, we put emphasis from agent to the memory. Now, human brain uses memory. Everybody knows it. We have short-term memory and long-term memory, right? You are now using short-term memory, which will remember all this environment, the speaker, what he did. That's all short-term memory. And if you go out of the door, most of people just forget it. That's not so important for your life. So right now you are using short-term. Now long-term memory is the one you want to keep a long time. So like memory about your parents, home, etc. These are all long-term memory. Okay? So most people know we use both memories to move around in the world. But I discovered that psychologists or neuroscientists, they found a third memory called working memory. Now, this is the memory somebody noted very good. Robotics didn't know at all. Or most computer scientists, they do know. They all thought memory is data. What working memory does is they take part of the short-term memory, which represent this current environment, and we have another part of the brain which remembers all the movement, or what I call skills, just push or turn right, twist, etc. And if somebody tell you, let's shake hands, then of course you have to use this movement memory and the current environment. And coupling those two allow you to shake hands, like this. Hello, sir. See, I use my short-term memory and part of my skills to move my arm. And that, according to neuroscientists, is called working memory. So which uses memory, part of the data, and movement. And that's exactly what robot needs. If you don't do that, the robot moves very, very slow. Most of the robot, even now, moves very slow. If you see the paper, all what you say, hello. Most of the mobile robot moves very slow. But if you look at YouTube, they look very fast. Well, why? Because they speed up 5 times, 10 times. Because they don't use working memory-based control technology. Okay. So that was a big innovation. And even now, some people, when they see me, say, Dr. K, you are the memory guy. This person knows I started using working memory. So one of the things you might remember from today's talk is a working memory. If you start telling other people what is working memory, then you can teach others. All right. So that was a bit of technical term. So let's look at more application part, which is probably more interesting to you. So service robot, when we formed a technology committee, technical committee within IEEE, we had to define the term and define the category, etc. And over the years, this service robot has become spread into the various areas. So these are some of the areas people are now working on. One is the domestic, second healthcare, third hospitality, fourth retail, five public safety, and agriculture. So let me go over each one very quickly. Now, this is the example of domestic service robot. Domestic service robot include vacuum cleaning robot. Probably you've heard or used Rumba. Mrs. Kawamura used Rumba at home. Anybody used? Okay. So this is a good example of service robot. Okay? One of my former students, Dr. Pat taught back. They remember better than I am. I'm losing part of my memory as you get older. But he was one of the engineer designed this. By the way, he was one of the first employee of iRobot. I'm sure you heard iRobot designed Rumba. And he used to tell me early days, Dr. Kawamura, work is very, very exciting. I'm glad I went there. But you never know whether you get paid next month. So he had to live month by month at that time. So anytime you start new technology, if you don't have a sugar daddy, it's very difficult. And other example I just picked from the internet as this cute, what's called Rita robot. Apparently cats can go there and do the one thing, and it goes to the tray, and the tray will be cleaned up automatically. There's a sensor, all kind of things. And lawn robot is another one. People thought this would revolutionize lawn cutting, but it's not working as much. And the last one is Pepper, which used our technology for the interface. So this is one of the most popular service robots. Even in this technical conference I went, I would say 50% of the people use Pepper to do the human-robot interface. To me, it's not much intelligence there, but for the non-robotist, this apparently is very, very exciting. So sometimes I get the fun of it, but showing our robot in the early days and the Pepper, they use exactly the same technology. Unfortunately, we didn't patent it, so I didn't get any loyalty out of Pepper. Healthcare robot. This is becoming very, very important. And we are the first robot group used robot directory for the healthcare. And now many hospitals use this $1 million surgical robot system called Da Vinci. And instead of a robot directly making operation, doctor look at the cancer, just like playing game, you know. and then he can or she can see the tip of the robot. In this case, more than one robot arm going in, and you can hit the human skins or head and operate how long it should go and cut certain piece, etc. And apparently this is very, very popular. Now, from technology-wise, this is not particularly innovative technology. This is exactly what the industrial robot tried to do 60 years ago. You try to pick up certain parts and put it into the body of the robot, you know, and they're doing exactly the same thing, but there's a very good sensor, very good gripper, everything is nicer, so they think this is a great technology, and for us, from technical point of view, not much. And the last one is a pet robot. This one is called Paro. And this Paro doesn't talk to you like Pepper, but when you touch, It'll make cute noise. If you squeeze too much, they'll scream. So apparently it's very popular among seniors in the senior center. And I was just told yesterday that this inventor, good friend of mine, he said this was a Japanese made one, okay? And he commercialized, and he visited many countries and tried to sell it. Now, since this is related to human, you have to get government permit to sell these things. And he told me, finally he got the US government approval to use Medicare to sell this. So now people like us, we can purchase this if we want. This costs around $5,000, so it's not that cheap. Hospitality robot. Well, these are the robots, for some reason, very popular in Asia. If you go to Thailand, Malaysia, there's a restaurant who uses those cute robots to bring food for you. Okay? And one on the left is a very funny one, but apparently one of the Japanese hotel used this kind of robot as a receptionist. So if you go there and start checking in, instead of talking to the human, you talk to the robot. I don't know if I like it, but apparently they're using it now. Now, retail robot is becoming more and more popular. So you see a robot walking around the aisle, checking all the inventory, see if you need to order more certain goods. And in some airport, you see the robot, so you can ask questions, which terminal, how to go from terminal A to B, or gate, so and so. And I was told even in some case, this robot will physically take you. I don't believe it, but it's technically possible. Public safety robot. Well, this is still a very early stage, and one of the speakers from Italy showed her work on robot in disaster response robot, and her paper was selected as one of the candidates for the best student paper, and I was a reviewer, and I was totally unimpressed. I told her her work will never work in the disaster response, but she got the certificate of being a good student paper. So for her, that was the main reason. She didn't care actually paper, her robot would be used in the real case. She wanted to write a good theoretical paper and get some award, which she did. Now in agriculture, robot is becoming very, very popular in a country like Japan or Spain, etc. In the United States, the land is too huge, so still it's not that popular. But you see a robot picking up apples, or in Japan putting rice plants, etc. So this is we are coming to the end, future, right? This is the exciting part. So what the field of service robot look like in the future? Well, now the field is really rapidly progressing, evolving, so it is not possible to predict the shape of the future in any capacity, because whatever I tell you may be wrong. So I will just mention key areas you should pay attention, okay, which will influence the future. For that matter, future of any robot technology. One is generative artificial intelligence. I'm sure all of you are using or have used ChatGPT, or okay, even I use it in my lecture. Some of my colleagues, he teaches Sunday school, he told me he used ChatGPT before he gives sermon in Sunday school. I don't know these folks use it, but I don't recommend, but anyway. But this technology, unfortunately, is influencing in the service robot, because service robot involves human, and if human everybody use ChatGPT or GAI, you have to pay attention. Machine, oops, I have a slide on that. Okay. So you see the fancy pictures, but you have to be a little bit careful. I'm sorry? In the aerospace. My hearing is getting, can you?
That particular one is used in aerospace on the area of the docking system.
Oh, I see.
Between the ISS and the rockets.
Okay.
Based on the working memory.
Oh, is that right?
Yes.
Well, I'm so glad.
Because it's adjusting itself every time by inches approaching between the docking system and the rocket.
Anybody who uses working memory is my friend. Thank you. Okay. The second ingredient is the humanoid. And of course, people like Dr. Iskaros and myself are very interested in humanoid robot. Now, everybody think this robot will dictate the future, but I don't think so. But anyway, humanoid robot gaining attention, okay, because all the environment we live in built to serve us, you know. We build the house so that we can live, etc. So obvious it is very logical to develop a robot which looks like us and behave like us. So there are lots of interest in humanoid robots. But we are still in early days, and potential is enormous, but it's not still not there. Now, there's one Jackman. Here he is. He thinks humanoid will come sooner. So, you know, if you like humanoid, maybe you should talk to Dr. Scarles. If you don't care too much, talk to me. Now, about 20 years ago, Disney Research, which is the research arm of Disney. Disney is a big entertainment company, of course. You know the Disneyland, etc. But they have a serious research group. And if you go to the Disneyland, of course, you see a mechanical automaton almost, you know, mechanical figure moving when you take a riverboat, some animal will come and try to get you, that kind of thing. So, 20 years ago, Disney wanted to invite experts and discuss the future of humanoid because they thought humanoid is a form of the human robot. So I was one of the panelists, and I met Dr. Engelberger there. And of course, he was the father of the industrial robot. So he said, I'm keen on the humanoid robot, but the appearance doesn't mean much to me. In other words, he doesn't care whether this particular robot looks like human or not. As long as this robot does what we do, that's fine. That was his perspective. And since I was a panelist, I just pick up what I said. Borg technology. Do you know what the Borg is? Cyborg. Probably you heard. Cyborg is the one, it's a human, but it has a super ability because it has a mechanical parts embedded. Okay. So it's called Borg technology. And a good example is this picture showed. If you had some accident and got your arm amputated, then it would be nice if somebody made a mechanical device which has arm and hands and attached to this your arm, right? And if you can operate it, then you recover many of the lost skills, movement. And actually this is seriously being studied and demonstrated. The difficulty is how to attach mechanical to biological systems. So, you know, this interface part becomes very, very difficult. And of course, the way we move our actuator is to send a signal through nervous system. And it's a chemical system. And so this interface is a very, very tricky part. But I was told that some institute in Chicago has successfully implemented. So one of the comments I made was, I think it's a little bit too early to discuss future of robot. I think it's more appropriate to discuss Borg technology. And of course, Disney didn't like that comment because they wanted us to discuss future of humanoid. But anyway, that's one of the comments I made. And then I just picked up two more panelists. One is probably you've heard of it, Dr. Sebastian Throne. He used to be the head of the Google autonomous car division. Before that, he was a professor at Stanford University. Before that, he was a graduate student in Germany, Technical Institute of Munich, where I first met him. He was working on mobile robot. And I told him, this is crazy. You should get out of Germany. And he later told me, I'm so thankful for you to suggest that. So he left Germany. But he's now a big shot and working on electric vehicles and e-VTOL. VTOL is the vertical takeoff landing vehicles, and this is the future of the robot technology. Okay, this is one of the technology you will see within the next 5 years. So he said, we are in a position to build a body, but I am not quite sure that we can build the brains. again, he was very, very smart. You see, he knew I was working on robot brain, so he was sort of poking at me. It's not easy to develop the human brain. Well, it all depends. Of course, we cannot develop the robot brain compatible to Isaac Newton, but we can develop robot brain not too difficult, compatible to, say, a high school student. Are you a high school? I'm sorry, I didn't mean to offend high school students. But what I meant is, you have to be careful when you make a blanket statement like this. That's the problem, by the way, AI fever right now. AI movement historically started 1950s, okay? And we went through the third wave, up and down. And this is the third wave. Since most people didn't know history, they only see this upward movement. So they think it's going to go up, and they will destroy human world. Well, that's a bunch of nonsense. It's going to come down. So that's what Dr. Suram doing now. I haven't seen him lately, but he's a very nice gentleman. And then we had Dr. Professor Mami Minsky from MIT. He was a very, very big shot in artificial intelligence. And AI technology, if you don't know, basically can categorize top-down and bottom-up system. And when I started working on AI systems, there are two groups. One was pushing top-down, which basically called the rule-based system. And the other group was bottom-up. Now everybody calls it database, right? That's where current AI technology dominates. But back then, those two groups fought each other. And each one told NSF that we are superior to the other one. And one was represented by the people like Dr. Minsky. The other one was, I don't remember, but working on neural net at that time. So, one group won, which is Dr. Minsky's group. So everybody at that time started working on the so-called expert systems. And I worked expert systems. I always said in the robotics, you need top-down and bottom-up. And the expert systems group promised too much, so eventually the other group won. So now the whole world is dominated by this database group. Large language-based machine learning, that's all database. The problem with database system is you never know how the answer comes out. It's like that's digesting duck, You you show the picture and they say, well, this dog belongs to late Queen Elizabeth. How do you know? They don't tell you. But anyway, so AI system is not one. And I had lots of problems with many presenters in the conference. They claim they don't know the history, the young people, unfortunately. So they think database system is the AI system, but that's totally wrong. All right. So machine learning obviously plays a big role. This is the example of Google. The problem of machine learning is they need lots of input. So this is an example of Google using the simple robot try to pick up some object among many laid on a box. And of course, depending on color and position, etc., you have to move robot differently, right? And this simple learning takes lots of time. So what they are doing, or I was told what they did, was they use this platform and run this robot day and night for weeks. Every day and night. Well, in this case, night doesn't exist because they always had the light right inside. Worked 48 hours doing all this. This failed, this okay. And after millions of try, they learned this skill to go to the specific object anywhere on the box. And I think that's the stupid way to do that, but they claim that's the way to implement machine learning. So, machine learning based on database, it's a data-based learning, but in our days, older days, we use another technique called reinforcement learning. And we always had a human teacher to teach robot how to do it. Now, of course, you can argue, well, what do you do if we don't have the human teacher? It's not like saying, what do I learn if we don't go to school? Well, tough luck, you have to go to school. So I still think reinforcement learning is a proper technique, but nowadays, everybody likes this brute force machine learning.
What's the difference between this one and the old machine, which is used for surface mounting PC boards? On the surface mounting PC boards, it's just kind of like, it's an old technology. Years ago, the robot was kind of like breaking up the component from several blocks and stuff it into the board.
Right.
And then the board goes to the machine and the machine soldered it.
Right.
And we end with a surface mount board. This is the same, right?
It's basically the same. It's just like industrial robot teaching days. In industrial robot teaching, what we did was often you can physically move robot arm from A to B, and robot record all that movement. And that's like reinforcement learning, So again, this is a good example of studying past will help you to design new way to do that. But you are absolutely right. We've done that. Obviously, people working in Google is young, energetic people. They don't know anything about the industrial robot, or they don't care. So they think this is a great way. So currently, I'm interested in cognitive robot. This is an emerging robot. And I will show you one article I recently published. If you're interested in, please look at it. But nice thing about the memory-based robot is, I just show this example. The person on the left is a colleague of mine at Vanderbilt, Professor Wilkes, and when we were working in the designing Isaac software architecture, he looked like the one inside this panel, so he was a little bit young, right? And this is how he looks. So, can you design the computer vision system which can recognize him when his database has only a picture like this? Now, we can do it. It's amazing. You know, I know Dr. Iskaros, how he looked like, what was when you were a student 30 years ago? And now I see him. Oh, Moniz, how are you? How do I do it? I don't know, but somehow, you know, we have a wonderful computer vision recognition system. And the only way current computer system can do that is using millions of data, and which must include current picture of Dr. Scarves, and then manipulate this so when you see his current picture, system say, Dr. Scarves. But I think the catch is to use memory. Now, how do you do that? I'm not a memory scientist, so I really can't tell you, but I thought one way is to design agent-based cognitive system. But anyway, so we had early architecture here. So this is the toward the end of my slide, cognitive robot, ultimate service robot. So when I was on the sabbatical, we went to Reading University outside London, and they had the cybernetics department. And before all this AI crazy came, the cybernetics is a scientific field to analyze human-robot communication. And, you know, I will guarantee you, if you go to this conference, I went, probably nobody have heard cybernetics. But 60 years ago, particularly at MIT, etc., this was the formal scientific way to analyze human-robot interaction or communication. Okay? So when I had the opportunity, I wanted to go outside, of course. And University of Reading had the cybernetics department. So we spent 6 months there, had a good time. And one of my colleagues was Professor Will Brown. He was a young, either lecturer? Yeah, I think lecturer. British University used different names. So his name, I don't remember exactly, but he was a lecturer. He is now the professor of the School of Electrical Engineering and Robotics at the University of the Real World. Have you heard of this? I've never heard of it. It's in Australia, Brisbane. Before that, he was at the University of Queensland. And then before that, he was at Reading University. Anyway, he was a co-author. So Will Brown, Cybernetics Department at the University of Reading. So I coerced him to write this book chapter on cognitive robot. So if you are interested in, either you can read this or a more recent article, I think it's easier to read. So I cannot define the cognitive robot for you because this field is just emerging. Okay? So I'll give you a few contributing fields, which include cognitive science, linguistics, computational neuroscience, mechatronics, artificial intelligence. So bottom field is a typical discipline being used to design and implement current robotics field. And the future robot needs input from cognitive science, linguistics. Linguistic, as you can see, it's already here through this large language-based system called generative AI. Computational neuroscience, that's needed for design the robot brain. And of course, we have to interact with human society. So, last year I was asked to write an article for the International Journal of Humanoid Robot to educate readers on this emerging field of cognitive robot. And I agreed to do that, except one condition. Still nobody knows the definition, so I won't define what the cognitive robot is, which they wanted. So anyway, I wrote this fairly general article addressed to general public, just like you people. It's called Perspective on Cognitive Robot Research and Development. So, if you are interested in, you can go to this journal, and it was published in December issue, I think. This is a 20th anniversary issue, and normally, just like many other journals, they will charge you. But this issue, I was told, is free. Okay? So, if you're interested, or even better way is I sent my copy to Dr. Gregory, so he has a copy. So he can give you a free copy.
I have a copy if you register with the QR code.
Good.
Then I'll send it to everybody who attended or even put it on our website.
Okay. So, this is the next to the last slide. So, what's the future? Well, I'll give you 3 examples. And as I said earlier, predicting future is a very risky business. So, you have to take this with a sort of grain of salt. Now, flying taxi. This, I'm pretty sure, it will come within 5 years. Okay? And of course, Dr. Sebastian Throne is working to develop this, and he's a clever man, so I'm sure you will see flying taxi within the 5 years. In care robot, this is a humanoid robot pushing wheeled people. Well, this looks very complex, but I think we will see this within 10 years, because mostly this robot doesn't need complex cognitive skills. All what this robot needs is a mobile robot skill plus a little bit of extra to control body. So I think it's possible within the next 10 years. I'll be so surprised if they don't do this. The last one is the one I really am interested in. It's called robot nurse aid. Okay? This is the humanoid type robot helping doctor and patient. And this is very, very important area to implement, because we have a great shortage of nurse in the United States and many parts of the world. And the population is growing older, like us. We are the good example. And so we need more, nurse service people. And I think this is a great area for robotic community to contribute. But my guess is we won't see this next 15 years. And Dr. Scars probably will disagree. We have to argue him after the this talk.
Doug, excuse me.
Oh, yes, please.
There is a robotic dentist exists in UK now.
Oh, is that right? Robotic dentist. Well, that's very interesting.
Yes, there is one which is can take care about 30% of the office visit. Not everything can do, but 30% is kind of big percentage.
Thank you. I didn't know that. By the way, when I had a sabbatical in University of Reading, I had a problem with my teeth, and so they have a facility called surgery. And the first said, well, Professor Kawamura, you have to go to surgery. I said, I don't want to have a surgery. He said, no, they don't operate you. They'll just diagnose and do the quick fix. So it's like a clinic. We call it they call it surgery. Interesting terminology. That's the problem, by the way, cognitive robot research. You have to interact with neuroscientists, linguists. You never know what they are talking about sometimes. So you have to learn the jargon first. All right, I talked too much. So this is my last slide. If you want to remember one slide, please remember this one. This is a cartoon, obviously, nothing scientific. But good old days, we all read the newspaper. And one of the attraction of subscribing newspaper was reading the comics. I don't know if you had the experience. Always Sunday paper had a comics paper. So that was a great anticipation. Sunday comes, you see the comics. And one of the comics I loved was this guy, which always involves this young boy and his dog. And this is one of the edition from the Sunday. And he was looking at his dog, and he said, it's a lion watching Loba, which is name of his dog, when he's dreaming. Okay? And he's dreaming, dog. And then pretty soon he started wiggling his tail. And so he said, cracks me up every time. What does he say? Honest, it's not the same. Okay. So, he loves dog moving legs. And then later when dog watch him, see if he does the same thing. And he said, oh, it's not the same thing. I don't know if you got the intent of this comic. But what I learned from this comic was this. One of the problems of robot technology, including machine learning, is you have to turn the switch on so that the robot will be in active stage. Then you can teach robot certain things, etc. And just like any graduate student days, you can ask Father Gregory, when he finished his work of the day, he turns Isaac's switch off, then Isaac sits still, do nothing until you come back to the lab next day and turn the switch off. So I thought, well, isn't that nice if robot can learn or dream when robot is not actively doing certain things. In terms of, say, machine learning, going over the experience of the day and learn how to correct the mistake, etc. So I just wanted to see if anybody is interested in developing a robot. When you turn off the switch, robot still do something. And the problem with that is robot needs sensors as an input, right? We also need sensors. When we walk from here to outside, if you don't believe it, just close your eyes and try to go there. Even if you know the location map of this building in your head, still it's not easy to go there. So we need a sensor. Now, when we go to bed, sleep, we don't get any sensor input. Yet our brain is working and we dream. And in this cartoon case, even robot can send a signal without getting any external sensor to actuate, to move the tail. You know what I'm trying to say? So, robot, of course, needs lots of energy. That's another problem. Just like electric vehicle, you know, mobile robot needs battery. In the case of Isaac, we always plugged into the source. So we consume lots of energy. So isn't that nice if we turned off the switch and we have some low-level power source and use that to rerun certain things. That's just my dream. It's always good to have a dream, I tell you. So please make sure you keep your dream alive throughout your life. We are reaching to the end of our life, so it's not easy to keep our dream alive at this age, but still I have few dreams I would like to realize. Okay, thank you very much. I enjoyed talking to you.
One more slide, actually.
Oh, one more? I didn't know. Oh, okay. So, I'll be stick around. Be happy to talk to any of you. My name is not easy to pronounce, so all students call me Dr. K. And if you want to call me Dr. K, I'll be happy.
We have a panel discussion actually with Dr. Kawamura, and it was supposed to be myself and Dr. Escaros, Monis Escaros, but I have to leave because my job is a priest, so I have to do a wedding in the valley. But I want to present also Dr. Escaros. He is a close friend of mine, and because of him, I came to Vanderbilt actually, giving him my application on the eve of traveling. But it's a lot of work in undergrad to do well in school in order to be able to be received in grad school, whereas you're all trying to do. This will have a follow-up relating to your careers, what disciplines you want to study. We'll bring some people who are young, working in companies now, different ages, what things you need to focus on if you're interested in the field. So you see as here is Monas, Dr. Skaros, here is with us now. He is the Chief Technical Officer of Embedded AI and Machine Learning at Infineon Technologies. He has more than 32 years of experience in the computer and semiconductor industry, focusing on AI and machine learning technology development. Monas received his PhD from Vanderbilt University under the guidance of Dr. Kawamura, as I was blessed by the same blessing. In neural networks, architectures, applications, and robotics, as we said, this robot system is a very multidisciplinary work, which is the beauty of it. So Monas worked on the control, I worked on the computer vision. My dream after seeing COG of MIT, it was to develop a humanoid, so I ended up building this human-like head and put it on the robot. And it's not one person's work, because I used the control systems that Monas had developed in order to move the hands, operating with the eyes to simulate a what was the work at the end became hand-eye coordination. Mo'nis worked at C-Cube Microsystems, Intel, SIMA.AI, SK Hynix, currently the CTO of Embedded AI ML to lead the Machine Learning Center of Excellence, as well as ML technology development. He has awarded 8 patents and published over 25 technical papers. He's passionate about embedded intelligence and believes that humanoid robotics is a major growth trend utilizing AI. So what was first built 25 years ago in the lab is now catching up because all of the theory then is applicable with the price of the hardware. I'll let him talk about this. So Mo'nis, would you please give him a hand to give us what is the state of the art now with humanoids. And they will, with the acceptance of Dr. Kawamura and Mo'nis, I will have to leave, but they will be here for any discussion, any communication later on. The QR code of the plaque outside, scan it, because it has the contact that you can register and can send you any papers for future work. Before I leave, I just want to, and before get Mo'nis there because he will take over and I will have to go, what are the implications as a priest leading or serving a congregation? Where it's important for our Coptic youth and community is as follows: great innovative career, and we need to be prepared early. It's a huge market growth sector with no slowing down. It's a great munching of AI, this very interesting mechatronics or machines that can think. Second thing, it's some amazing, cool things to work on, and don't dream like you're going to get into just moving a robot right away. Do the basic math and the basic science very, 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 very well at this point. Then later on, when we focus on undergrad and we did well with the subjects we had, then you can be powered to work on these systems later on. Don't be absorbed into this massive AI vogue without knowing the basic engineering, the basic math, the basic science. It will become so helpful. Linear algebra, calculus, all of these are the engines of that move even AI today. So third point, which is important for me, is how the human thinking happens. I want to show that this is relevant to the Coptic Orthodoxy, how our faith actually is also data-driven and concept-driven, and the mind creates the mapping between the two, and it's very comfortable for this map. So later on, inspired with how AI is a representation of our thinking outside, especially neural networks, that's why it's called neural networks, the neurons of the brain. Take data and then you show it something, it builds the map between. This is actually built mathematically. Our mind builds it with stronger connection chemistry. So is our worship as data and the concepts of the faith can be comfortable for the human mind or not? That's a personal interest, and of course it's very relevant to understanding the faith more. I'll have to leave, but I'll leave it in the hands of Mo'nis and Dr. Kawamura, and we'll meet later tonight if we can. And please hang out with them if you have any questions. I will get the contacts, I will share it. Just register with the QR code. Thank you.
Thank you. So I wasn't really prepared to do any presentation, but I put few slides together just in case that there are some questions. Earlier when I met Dr. Kawamura, he told me, you're interested in humanoids, but it's not going to happen for some time. And I told him we'll spend the rest of the day trying, hopefully to convince him that it's not that far. Actually, I agree with Dr. Kawamura on many things. First of all, it was a great opportunity that we had that at Vanderbilt, really that center of for intelligent systems and intelligent robotics, way before its time in terms of the vision and what we worked on. And we went through. Probably I went through one or maybe two of these cycles of AI and what's called the AI winter, the big time after the big hype of AI not delivering, and then all the research and funding was depleted, and people were not that interested, and then things start to come up 10 years ago with mainly deep learning and lots of new ideas. So talking about very quickly, at my work, one of the things that I do is that try to talk about trends for the company. What would we work on? And a year ago, or a year and a half ago, I gave few ideas or few growth trends, and I gave some timeline. And it is being consistently now that every prediction or timeline that I think of, it happens way before. So one of them was generative AI, and at that time ChatGPT was out, the big hype about generative AI and the use of things like large language models and ChatGPT. And by the way, I've been tracking this since 2019 with very early versions of models. And I thought that it will take at least 3 to 5 years until it becomes in a form factor that is what we call the edge form factor. The edge form factor means that it is not running in the cloud or in the data center, but it is running locally on embedded devices, and probably you carry it in your phone or other embedded devices. Actually, less than a year after that, now we have devices that include large language models and capabilities of ChatGPT completely enclosed within embedded devices, embedded systems. And it is now, there are companies that, for example, there is something called AI pin, where it has a camera and you can communicate with it. It's a pin that you attach to yourself, and it can see what you're doing, everybody in front of you, and you talk to it, and so on. It's a little bit hyped up because the technology is not that mature yet, but these type of development is happening. Same thing that thank you. Same thing with humanoids. And I'm going to show you a few things about humanoids that are really very impressive. It's still picking up. It's still on the growth path. But things are progressing even quicker than what we thought. And this is, by the way, what is called now, there is now a new term called physical AI. Physical AI is the embodiment of AI in physical systems. And uh, i- humanoids is a great example of it. A year ago, this picture was actually showing existing development of humanoids, and I can go through them one by one and tell you where they are and what they are doing and their stage of maturity. But just to mention a few, this one, for example, the second one is from a company called Agility. Agility is in Oregon. They are actually building a factory to build up to 100,000 humanoid robots per year. They are ramping up this, and this is for logistical and warehouse usage, and it is being used. Let me pick another one. This one actually, Figure.ai. Figure.ai is in in Sunnyvale in the Silicon Valley. They have now 2 generations of their humanoids. If you search for Google them, they have very impressive videos. I actually know them very well. These are not mock-up videos. These are actual videos of interaction between the humanoid and people, and this actually uses the OpenAI large language model from OpenAI for the interaction. This is tracking a very similar picture of tracking the top ones. And by the way, you probably have heard of the one by Tesla, which is Optimus, and they also have 2 generations of it, Optimus 1 and Optimus 2. So these are actual systems. The one that if you go and try to search for it, that is, in my opinion, is going to be available faster or quicker than others, is by a company called Unitree. It's it's a Chinese company, and the positioning of the humanoid robots is currently starting to for industrial applications, to industrial settings, to be used in industrial settings. Then it will be more in assistive and in retail and some of the assistive environment, and then probably healthcare will come later. So actually, when Dr. Kawamura mentioned that healthcare is in about the nurses in about 15 years, I think this is very probably true, very reasonable, because there is a lot to do to reach that point with that functionality. But earlier there are the applications in other application in industry and logistics and so on. These are actually more of the details, and these are you can look them up, all working systems. As an example, these were few articles that pop up almost every day, every week. There are many articles about new humanoid robots that come into existence, or research that's being going on. And a typical one, it's as Dr. Kawamura mentioned earlier, this is a field, it's a multidisciplinary field that includes AI, electromechanical systems, sensors, power, memories, a lot of software, and also understanding of how to interact with humans and so on. So I think just my last comment here is, aside from humanoids and AI, there is now really a a large or a big trend of growth in technology in these two areas and other adjacent areas. And if I try to think, what does it mean to us here as a community in the church here or in other Coptic churches? What does it mean to us? Because in some cases, there is a resentment of new technology, or this is something. What is it? Are we going to replace humans, or is this going to become? There are lots of talks about when the intelligence can exceed the human intelligence, and what would happen at that point, and so on. We have to really understand what this means, because it's not as simple as this. It's not as simple as that AI could take over, or there are lots of different ideas and theories and predictions. But what does it really mean? How can we, as a community, and you as youth and studying, and you will become professionals very soon, work in this field and understand how to use it and leverage it to the best of the community and service. So my advice is, you have to learn, you have to embrace the technology, you have to use it towards the improvement and betterment of the community and of yourself. Don't be shy to dream about technology and innovation, and have a vision, or learn about visions from others. And later, if you want, we can talk. I can give you several recommendations about things that would help you in creating and learning about these visions. Thank you very much, and if there are any questions, I'd be happy to entertain it.
So I'm a teacher by profession, and I noticed that as we use AI to process tasks, it starts taking that ability of ours. We don't practice it anymore, we just become evaluators instead of us generating the ideas. So my first question is that, could potentially too much reliance on this technology cause a stagnation in human cognition?
I don't have a good answer to that question, but I can tell you my thinking. First of all, if you think when computers started and everybody thought that this is going to make people do not think as much, or the reliance on computer and the machines, but this did not happen. I think we always adapt to use it and become still ahead of it, that it is a tool for us to use. We do not become a reliant or completely enslaved to it. And I think that this will happen with AI and with all the different capabilities that AI can bring. Dr. Kawamura, you want to?
Okay. Now, that's a very good question. I think we as a teacher feel the same way. I've been teaching engineering school for 40 years. And one of the things I realize is students tend to rely too much on software. So good example is I teach control systems, and when I was young, we had to learn all the physics, mathematics before we apply that to the control system, open loop, etc. Now, if I go through that, probably I will lose three-fourths of the students, you know. To retain student interest, teacher also have to rely on software, like we use MATLAB, etc., simulation. And I think that's the inevitable process. In the real world, student, graduate will use those softwares. What we can do as an engineering or teacher is to teach student limitation and advantage of this system at the beginning, so that student understand the limitation of this software. Otherwise, just like this current, to me it's a crazy trend of everybody using ChatGPT and rely on that. Like God, you know, I use this and this is what I got, so I believe in it. And that's the danger we are facing right now. So I don't disagree using those software in educational environment or any environment, but we have to teach users limitation. That's the problem of, say, humanoid as well. When I was developing humanoid, we often invited school kids to show our humanoid and ask them questions. And of course, most favorite question they ask is, does Isaac do the dishes, clean dishes? Second question is, does Isaac solve my homework? You know, they have a very different perception about technology. So we have to educate the public or teacher or student limitation of this technology.
So my second question is more about the social implications of humanoid robots. So I'm going to give a little context. When the automobile was invented, it made streets wider, it separated neighborhoods, it became just blocks and blocks of houses or shopping centers. And the way people normally interacted was walking through the streets. So that started getting rid of this idea of community and friendship. And then when the internet came out, it created another boundary, to the point now that 50% of relationships start online. And if they start online, 75% of them end within the first year. So what social decay might happen if humanoid robots become common? And I'm looking just at I want to look at both sides. So tell me the bad things that'll happen and tell me the good things that'll happen.
So bad things would be to rely on it and lose all the human interaction or human touch. You have the example of the pet that a person would relate to and like. It could be that a humanoid or a form factor that is doing some assistive work and close to people that they feel that that's enough for them and they don't need any other kind of of interaction and relation, and this increase that gap. I think that's a possibility, or it will probably happen in one way or the other, one form or the other. However, the upside of the benefit is also there is a good amount or good deal of benefit, because as Dr. Kawamura mentioned, the elderly community really need help, that there is a shortage. And Japan actually has a very high percentage of the elderly community, and it's a big shortage. And now it is happening in the United States and in Europe and in other parts of the world. Assistive robotics or service robotics would be a big benefit to the community. Actually, the one of the main reasons and big drives for some of the companies that I showed building humanoids is for industrial applications, because there is actually shortage of workforce. It's not that they are going to take over or they will lay off people in the factory lines because they are bringing in robots, but they cannot even find enough workers to operate these. And also in terms of safety, there are lots of hazardous activities, whether moving things around that very or in very hard or hazardous environment. So, and this is actually one of the big drives. If you listen to some of the founders of these companies like Figure.ai, by the way, Figure is their humanoid is already used in the BMW factory. It's in Tennessee or in Georgia, one of the factories there. And it is deployed there. It is being used. So there is, of course, a big upside and big benefit. But also there could be some negative sides of it.
Okay. So deploying humanoids is what everybody wanted to do. He's working on that. I started my work on that. The problem with humans compared to, say, rumbar or even electric vehicle is humanoid is very, very complex. And so you see a nice humanoid like Dr. Scott showed. The problem of applying that technology in the real world for a long term is every machine will degrade over the years. And who is going to maintain, who is going to repair, this will cause a major problem. Of course, in the research industry, like us, university, etc., we don't concern with the long-term effect, you know. We just want to build a new one and see if it works or not. Who cares? 10 years from now, I'll be dead or I'll be doing something else. But this will cause a major problem. And I would like all the young fellows working on the humanoid should think about it when they design. You have to use different kind of design techniques to build humanoid. If you expect humanoid to be widely used in the public for a long, long time, maintenance, repair, and of course, improving software is easy. Now, if you buy a car, they'll revise your software regularly. That's not the problem. But hardware replacement, unfortunately, cannot be done that way. You have to replace physical parts, right? And humanoid technology will face that problem. Now, one of the benefits of EV, electric car, is compared to conventional car technologies, parts is a lot smaller, maintaining is a lot easier, but they have their own side negative effect. So you have to look at from short-term basis, long-term, you have to think about how to deal with negative effect differently.
Actually, I want to tell you a short story, a comment about what Dr. Kawamura mentioned. In one of the trade shows a few months ago, one of these systems was being running and shown working and doing different tasks continuously. And of course, say that you can run them 24/7 and it will not, it's multiple shifts rather than having people working only 6 hours or 8 hour shifts and so on. And very low maintenance and so on. But that one was running continuously in that exhibit, and it collapsed. And people looked at it and said, "Oh, it's even like human. It gets tired." No, it's not. Of course, it's a machine. If you are driving your car 20 hours, something will happen. So it collapsed exactly as a machine. It's a very complex machine, and probably it took a time of from 2 engineers, multiple hours to fix it or to debug it. But that's a very valid point, that we need to understand the problems that it can happen because of it, or the implications. Another one that is very, very critical, and people whether avoid talking about it or avoid that it would happen, is that the use of the robotic technology, whether humanoids or other quadruped or things like the Spot and other robots in the military. And unfortunately, this is happening.
Can I add one? When I mentioned you have to think, design differently when you work on humanoid, one interesting example is a mobile robot called Aibo. I don't know if any of you have heard or see Aibo. It's a dog-like robot, and you can talk to them, give command verbally, and this little dog react, move head and nod, etc. It's a very early entertainment type robot Sony made, and our group didn't do much about mobile robot, so we didn't have interesting mobile robot, but students are interested in. So we purchased one, and students played, and after a month or so, when I go to the lab and said, "Where's Aibo?" Aibo was sitting on a shelf. And then one time I had the opportunity to visit Sony lab where they developed Aibo. So I talked to the chief engineer, what's the key part of designing this robot? And he told me an interesting story. He said, well, we had to sell this robot in a big scale. So obviously if something goes wrong, we cannot send Sony engineers to United States or Africa to fix this robot. But we had a very clever idea. We designed this robot simple enough that people get bored after a while. So we want to make sure every part works for 3-4 months. And he was very clever in human performance. And sure enough, our graduate student got bored after a couple of months, so stopped using. So they don't have to call Sony and said, well, we have a problem, you know? And I thought, well, that was a very clever idea. But then think about humanoid. Compared to eyeball, humanoid has thousands of parts. So the possibility of some parts getting bad is not higher than eyeball. So if eyeball's principle is to make sure it works 6 months, human has to be able to work 6 years. So can you design a robot which can work 6 years without repair? I don't know. Maybe clever people like Dr. Iskaro's company can do it. But I thought that was an interesting comments I heard.
Yeah. More questions or comments?
I think most of us here kind of, yeah, sorry. So just to set up like a backstory, I think most of us here kind of grew up in the internet age, right? And we grew up seeing how the internet has evolved and changed, and how it started out as something meant for good, something created to help connect people, but it ended up growing up into things like Instagram, Twitter, where people are always arguing, or it drives people apart. So as engineers, and as people who want to build something good for the future, how do we make sure our technologies don't end up being used for bad by companies that just want to make money? How do we make sure that what we create doesn't end up being used to walk around and try to sell products, or to start whatever, you know? How can we do our part as engineers to make sure our technology is used for good as we intended?
That's a tough question. So I tell you a personal experience. After graduation, after finishing my PhD, I came to a company here called C-Cube Microsystems. C-Cube Microsystems was at the edge of technology in developing digital video hardware chips. Okay, and we were the first company to have a DVD chip that is being used by all the DVD players at that time. Okay, and I struggled myself with this. So I'm part of that development of that technology and developing this chip. And as many benefits of having that technology or the digital video technology, and of course now it's all over, there are also negative sides of it. And first of all, I have no control on it in terms of developing a technology developer. But I have control in terms of the usage. So I don't want you to be limited or to limit yourself in terms of the technology development and the engineering work if that's what you're doing, because of how this is going to be applied. unless it is something that is really obviously going to be very bad and very hurtful. Okay, but I think you should be more in control of how you use it and how you advocate it's being used, and also within the community and within the church and within the youth group and your teams. That's where I think you have a better grasp and better control, rather than technology is a technology. It's not really good or bad. There is no good or bad technology except in very few cases.
I didn't hear the question clearly, but can technology be bad, or what was the...
Yeah. So as a technology developer,
Mhm.
and then there could be a negative effect of that technology or bad use of that technology. How can
Well, that's a difficult question. I'm sure lots of people have seen the movie. What was the movie discussing this atomic bomb development, Manhattan, Oppenheimer? The title was Oppenheimer? Oh, okay. So that's a good example, right? When Dr. Einstein, etc., was worked as a pure physics research, that was one thing. And when government decided to apply to make a bomb, then that's a different story. So how could we solve that problem? As the technologist, I think it is a moral decision to certain degrees. So some people decide not to participate in the development or applying that kind of technology. Some people just ignore that. And I don't think anybody can tell you how to do that in that kind of a situation. There are lots of factors influencing your particular decision. So ultimately, it's your personal decision, okay? And the factor may be religious, factor may be economic. You have to combine all this, and there's nobody outside you to tell you what to do at that point. I used to tell students, you have only one life, but you have lots of opportunities to choose different paths throughout your life. And so anytime you make a decision, please think carefully. You have to think long-term effect as well as short-term. In the short-term, everybody does that. Location, salary, etc. So you tend to use that short-term data to make long-term decision. That's the difficulty of choosing social decision, including technology. I'm sorry, I can't give you yes or no answer. If somebody give you a yes or no answer, I think it's a fake.
yes?
So I'm more interested on the perception aspect of this project. So I'm a computer vision student. I'm doing my master's on computer vision robotics, and I personally think the perception algorithms which we have right now is actually not very practical. So with that being said, do you really think the perception technology we have right now is going to make a difference in these projects?
What was the last question?
So I think the perception algorithms which we have right now are not really advanced.
Well, yes, I agree. If you look at the history of computer vision, it's It's not just short term. We started a long time ago. Government spent millions of dollars, and hundreds of people, including graduate students, worked. And look at the current technology. I perfectly agree. I'm not a computer scientist, vision people, so I always tell those people, you guys are crazy. You are getting so much money, and look at what you are producing, right? So I agree with you, but on the other hand, it's very difficult to tell when this technology will reach to the level of human eyes. Our eyes are fantastic, you know? Like I just mentioned him, I could instantly recognize him after 30 years, for instance. Unless you look like Father Gregory, then that's a little bit more difficult, you know. But computer vision is a problem if part is occluded and if part is. I think one of the problem is they ignore the total environment. They just look at particular object and try to and when we recognize certain object, we unconsciously use the environmental information as well. So that's where I think weakness of computer vision comes in. As I said, I'm not a computer vision expert, so I really didn't have a chance to discuss, but the more they do that, I think the algorithm will become robust. I'm not sure if I answered your question, but I certainly agree with you. It's not good enough. I'm not discouraging you to continue in the computer vision field, but I am a little bit negative.
Question?
By the way, just to keep you feel better, when we started Isaac, of course, computer vision system is even worse. You know, I was really poor, but we had to use computer camera to locate people to feed. So I told the student, well, let's do some trick. Human is a very, very intelligent agent. So you don't have to accurately identify human mouse to feed this person. As long as you approximate and go there, human can, do the rest. So I think that's the advantage of integrated system. Some part of the system can augment weakness. So rather than trying to develop perfect computer system, maybe you should think about total system. Hope that might be helpful.
For students that are like learning, we usually like get the same curriculum. All of us learn the same things or close to the same things. So when it comes to finding like inspiration, like you mentioned, you had inspiration from Dr. Engelberger. Like, how do we go about that? What's the process of like discovering or maybe thinking up new ideas that could potentially be the technology of the future? Where do we go from there?
So the question is, the students are going through a curriculum and a similar curriculum, but how can the students discover new ideas and have a chance to learn, like examples that Dr. Kawamura mentioned? Is this the gist of the question.
Okay. Is it working?
Yeah.
Okay. Well, I tell you what I teach my students. Okay. Don't just focus on your own discipline. So, if you take certain classes and you learn how to semiconductor works, how the mechanical system works, how sensor works, that's fine. But as you said, that won't give you much help to develop new things. So, open to the other field as well. Yeah? In universities, we are trying to go into more interdisciplinary, but we are struggling ourselves how to do that, to teach students interdisciplinary topics. And some schools have to teach courses. Most universities still, if you are electrical engineering, mostly you have to take certain courses, and you have very limited optional courses you can take. But unfortunately, you have to open your eyes and your own initiative. Using your own initiative, you run some related field. I think that's the key right now. Sorry, we are, as an educator, we are to a certain degree failing you to be more interdisciplinary, but that's what needs now.
Actually, I'd like to add, there are now, of course, a lot of information and opportunities to learn, whether it's online classes or just watch videos and articles. But two things I really feel are very useful, at least for me. I get almost maybe 10, 15 different articles feed every day. Just subscribe to different feeds with your interest and go beyond also your interests, so all different or adjacent areas, and make it a habit that every day you check them out, at least learn what they are all about. If there's something interesting, read about it or look at their video and so on. I see this, or I feel that this has been, for me, very useful to keep up with what's happening and beyond my immediate technical kind of interaction or field. The second thing is, and this may sound a little bit strange or weird, but I am a fan of science fiction, whether it's books or movies. And if you look at the science fiction and the trend of technology development, there is science fiction usually has a very good prediction or ahead of what's happening. And at that point, when it happens, when a book comes out or a movie, we call it science fiction because it's not reality and it's far off or far out, but actually it happens later and much faster than what we think. And actually I learn a lot and I get a lot of inspiration from sci-fi books and movies and not the very weird ones, but things that could be happening.
Yeah, I agree. Now, my slide shows that I got the inspiration from science fiction. I slightly disagree with Dr. Scarus. I don't think you should put too much your face on the science fiction. You know, most of actually science fiction future doesn't come true. So you get the important thing is you should get the inspiration, but don't just believe they will come in the future. Some technology in the science fiction will never come true. But in my case and his case, we got lots of inspiration, and that was very, very useful. And I also encourage you to read science fiction. It's very fun, at least.
More questions? Okay.
Professor, okay, this is straightly to you. So earlier you mentioned about reinforcement learning, right?
Mention what?
About reinforcement learning.
Yeah.
Yeah. I really want your opinion on continuous learning. On continuous learning. So, right, it's actually not very, but as I understand, this is like the new field that's just emerging out. Even my professors couldn't give a solid definition of that. But I've been reading about it in some articles, mention of it.
So I'm not sure. Those are two different areas, you know. Reinforcement learning is used for short-term learning. Continuous learning is quite different from reinforcement learning. So I'm not sure what was your question.
So every professor asks about continuous learning, they have their own opinion. So I just want to hear your opinion on continuous learning. And, yeah.
Okay. Well,
maybe your definition or...
I see. Yeah, the continuous learning meaning you are updating your knowledge base continuously over the time. That's my understanding. And is that what you are talking about?
Yeah, so there are some fields like...
Yeah. Okay, so here's the problem with continuous learning applied to robotics. Okay, our dream of deploying robot is, like I just said, well, we don't want to just develop robot which lasts 1 month. We would like to develop robot which will be operational for many years. And of course, we would like this robot to learn new things, right?
Yeah.
That sounds very logical. You know what the problem is that most people don't realize. And I'm surprised how ignorant those people are, because they've never deployed robot long term, you know? The problem is robot brain currently is made of silicon chip. And this was a great advantage in the past because you can start using machine learning system and add lots of information, you know? And so you think that this robot gets very clever. That's what the current autonomous robot people are doing, using many sensors, going out, and get all the informations, improve the knowledge base so that you can navigate better. The problem with that approach is sooner or later, if you do that in a complex situation, your brain will start telling you that this part of the memory will tell you to go to left, this part will tell you to go to the right, because knowledge will change over the time. Even medical knowledge changes over time, but as long as you use silicon-based computer system as a brain, they won't forget anything. Nice thing about human is we have a capability to forget old technology or bad technology replaced with new one. And how can you design the robot based on current chip technology to do that? To improve continuous learning, well, I don't think anybody knows that. The problem is they don't know they don't know. You know, that's the problem. Because we never deployed robot for the years. Technology is too new to test. So every time you go to the conference like I did, people say, well, we developed this social robot, deployed, and use 50 people to test it. Well, so what? I mean, you can test with any people for one day and see if it works or not. Can you do that for the next 10 years? I never thought of that. Because technology is too new for that. So I'm sorry, you know, I lived long enough that I see too many problems, but the continuous learning will definitely cause a problem.
Thank you.
Any more questions? Okay, so with this, we want to thank Dr. Kawamura for coming here, and it has been a pleasure also seeing him and being hosted by Father Gregory, and thank you very much for coming.
Thank you. Well, I just retired, you know, after 40-some years, and so I'm missing interaction with young people like you. So I was very pleased to be invited. Thank you. Oh, thank you. So I'll be happy to chat with you, you know. You can ask anything. I don't promise to give you the answer to every question, but I have a little bit more experience than you, so I'm happy to